Okay, this is the solution to one of the problems concerning a committee selection. Okay, problem number 55. A resort manager is choosing a committee of 4 people to discuss employment issues. He'll choose from 8 housekeepers, 3 desk clerks, and 5 maintenance workers. How many possible committees are there if there have to be at least 2 housekeepers? So first of all, at least 2 means 2 or more. This means that there could be exactly 2 housekeepers, exactly 3 housekeepers, or exactly 4 housekeepers on the committee. This is the setup for this problem. As you can see here, we have 4 blanks for the 4 committee members. And the 3 possibilities, exactly 2 housekeepers, exactly 3 housekeepers, exactly 4 housekeepers. If we have exactly 2 housekeepers, then the first 2 blanks here are for the housekeepers. And we're looking at the number of combinations of 8 things taken 2 at a time, because we have a total of 8 housekeepers, and we're taking them 2 at a time to complete our committee selection here. So we have the number of combinations of 8 things taken 2 at a time. Now, for the next 2 blanks, we can have desk clerks, or we can have maintenance workers. Now, there were 3 desk clerks and 5 maintenance workers, which makes a total of 8 for the second 2 slots in this case. So we have combinations of 8 things taken 2 at a time for these 2 slots here also, because we have 8 desk clerks and maintenance workers. So when we put this into the combination formula, we come out with 28. For the number of combinations of 8 things taken 2 at a time, we get 28. So that means we would have 28 times 28, because we have to multiply those 2 numbers together. You see, this can be done in 28 ways, and this can be done in 28 ways. So together, we multiply them together to find out the number of ways they can be done together. That's the fundamental accounting principle, also known as the multiplication principle. And 28 times 28 would give us 784. So that's how many ways we can do that with 2 housekeepers on the committee. Next, exactly 3 housekeepers on the committee, because when you say at least 2, that means you can have exactly 2, exactly 3, or exactly 4. So for exactly 3 housekeepers on the committee, we would have the number of combinations of 8 things taken 3 at a time for the first 3 slots. You see, this deals with the housekeepers, these first 3 slots. And then we only have 1 slot left. We have 3 desk clerks and 5 maintenance workers, making a total of 8. So we have 8 things taken 1 at a time for that last slot. So we just plug these into the combination formula and then multiply them together. So number of combinations of 8 things taken 3 at a time, we get 56. Number of combinations of 8 things taken 3 at a time, we get 56. 8 things taken 1 at a time, we get 8. So 8 times 56. That would give us the total number of ways that those two things can be done together, and that would be 448. Now we just have one more scenario, and that is 4 housekeepers. That means everybody on the committee is a housekeeper. So this time we only have the combinations of 8 things taken 4 at a time, because we're talking about all housekeepers. So we just plug that into the combination formula as we did before, and we get 70. And then we add those numbers together because it's an OR situation. You see, OR means union. So you can have this or that or that. You can have exactly 2 on the committee, or you can have exactly 3 on the committee, or you can have exactly 4 on the committee. And of course that means, OR means that we have to add those together. So we don't have any intersection there because it's exactly 2, exactly 3, exactly 4. So we can just add those numbers together. So when we add 784 plus 448 plus 70, we get 1302. So that means that there are 1302 there are 1302 ways that the selection process can be done based on the specifications in the problem. Have a great day. I hope this has been helpful.